60 intelligent. So, 340, 5D, 60 intelligent BIM solution. So this will discussed very shortly by my colleague, Mr. Madhusri Kumar. So we are also a multinational member of Building Smart, which is an apex body and benchmark for standardization and interoperability between open BIM solution. We are basically into integrated BIM project management. We are also into BIM education and implementation. So that is a big reason we are here today. So since we started in India, we are also having tie-up with leading education and education institution. One of the prominent one of them is IIT Palakkad in Kerala. So we have signed an MOU with them. It's agreed that they introduce Excel into their curriculum and a joint research program on the ongoing construction of the campus. So it's around 500 acres. So we are also in final talks with several NITs and IITs. So the idea is to implement Excel in their curriculum, first by research and solely into civil engineering students. This is going parallel. So we are also extremely proud to say for the past 5 years, we're also always in the top 5 companies for innovation and implementation award category in Building Smart. So next slide. So there are various project value managed with Excel Manager in the different sectors in the construction industry. The project value managed with Excel Manager in the last year itself is more than 90 million USD. So most of the Excel Manager users are project managers and contractors. This is just a graphical representation of whom Excel Manager serves and which all industry we cater to, which is basically every industry. So now the question comes, what is the requirement for them or any kind of open BIM standards, and how it is going to help the students? So this is the big question, right? Because you guys are going to be the next generation who's going to work in the disrupted and revolutionized AEC industry. So most of your faculties would also know there's a significant change that is happening in the industry right now. So, but the main question is, I'm talking a lot about BIM. So most of you would be thinking, what is BIM? But you might have heard about it also. It's building information modeling, which is basically a process for managing and creating intelligent 3D models. For example, if you are making a smart city, so it just makes it from its infancy and how to plan, how to design and construct and operate in an effective manner to how it looks in the future in a 3D manner before it is becoming constructed. So our product Excel Manager takes it a step ahead. So that is what we do. So the current trends in the industry should be an important part of any AEC student's education. And it is crucial to become familiar with the software processes used in nowadays professional life. So I'm just going to help a student. So it's basically higher chances of getting hired for the internship and jobs. It's not only for our company or any other companies out there, and more or less the infrastructure and planning ministry is backing up new trends in the construction industry. They made it possible for BIM used in most of the new metro rail projects. So BIM is everywhere, but it's still in its youthful matter, But within 5 to 6 years, BIM is going to be a household name in the construction industry. So it helps you produce drawings more efficiently, allows you to access various visualization and analysis tools, easy collaboration in group works and clash detection, less duplication of work. See, these are the things I can tell you. But apart from getting a job or an internship for you guys, more than that, you don't have to know many things. But these all things is helpful, and it saves a ton of time when you start working. So then it becomes so much important for you guys, especially for the students out there. And if you are a student who wants to get into the IT background of the construction industry also, it helps a lot. It's in the, when you are actually getting into the working field of it, it just helps you a lot. So anyway, anyone looking for a career change in the AC industry, apart from a site engineer or anything like that, it's very much is understood that they should understand BIM, open BIM standards, and integrated BIM management too. So this is the future, you know. So the construction industry is urgently looking to attract new talent who are well versed in technology, have BIM skills, and are comfortable using cloud applications like our programs. And those people who knows about the BIM standards are always welcomed into the industry with open arms. So it's actually been representing a new paradigm within AC industry. So that one that encourages the integration of all the roles into the construction industry right now. So let's talk about some of our clients. So these are our clients. As you know, these are some of the big players in the AC industry. As UN is pushing forward to create a better world through sustainability by 2030, our collaboration with these big players can make a great impact for them as well as for us. So because of the integrated system we use, so it is more sustainable in the long run. So that's why we have a lot of clients. We are working with them on different projects. So next is the situation in the industry. Madhav, next slide. So the situation in the industry is that, our CEO, Mr. Ajit Kumar, he's the CEO of Bexel India and Bexel Gulf Consulting. So he's a seasoned expert with 41 years of worldwide experience in construction and some contract management. So in subcontract management. So throughout his inspirational years, he has worked on some of the world's most successful oil and gas projects. So after years in the industry, he always tells us that India's construction industry badly needs to embrace digital transformation in order to improve efficiency, productivity, and save time. It's save time and cost both. So this is being wasted in large measures in today. The relevance of the AC industry cannot be underrated at all. So it is the second largest industry in India and one of the key drivers in the country's economy. So, there are a lot of government initiatives to boost AC industry too, but by the Ministry of Statistics and Program Implementation says at least 355 projects have been a cost overrun of rupees 3.88 lakh crores, and about 522 projects have faced, time escalation. More than whatever time they have given, they always need a lot of time more. So this is bleeding of money. But these all problems are already happening, then the pandemic hit. So the construction industry is not shelling out, big money. It's always, a lot of money is put into this particular thing. So the impact of the pandemic in India's construction industry is costing an estimation of rupees 30,000 crore every day. So this will reduce the investment in the construction industry by 13%. So, this is a problem for the employment and the gross value added, but the government is optimistic. It's about it. They think implementing BIM would save 20% of construction cost. So I'm not going to bore you again a lot about it, but now we have a very qualified person here to discuss the situation of the industry in depth and the technical aspect of our product and a little bit about BIM. Madhav, over to you.
Thank you, Lakshmi. Actually, you have set a very good pace and introduction, gave a very good context of why we are going to have this webinar and why BIM was required in the first place and why we started thinking about construction productivity. So situation in the industry, as Lakshmi rightly pointed out, is it has always been messy. Like India especially is very fragmented construction industry and where technology adoption rate and everything is very low. So let's look at some numbers. We can say things are messy, but is the numbers showing the same thing? Let's look at the numbers. What do the numbers say? When we are comparing manufacturing industry with the construction industry, and we are talking about all these numbers, we are going to see a few more numbers on this slide. We are talking about the productivity and the productivity aspect of all the work that is entailed in both the industries. We'll see that when we come to manufacturing industry, the value addition in terms of productivity is at it's more than 50%, and that is good enough. Like there is always going to be some wastage, some leakages of data and efficiency, like understandably, and 62 is a very high number. But coming to construction, yeah. So coming to construction industry, the value addition is a mere 10%, and that is not because of the inefficiency of the people involved in the construction industry. It's because of the challenges we face. It's, for example, a manufacturing industry, a industry that manufactures a car. Car is located in one geographical location that a person, there is a continuous leadership and curiosity into developing what is the inefficiency and how we can improve on it. Whereas coming to construction industry, we do not have any roots. We go to wherever, whichever geographical location that needs a development, infrastructure development, we mobilize a lot of people and resources to that place, and we keep in the struggle to manage this huge array of activity. We tend to lose sight of the importance of productivity and how it can be managed. There are things like lead construction management that is looking into taking good part of good qualities of the manufacturing industry and bringing it into the construction industry. So yeah, manufacturing industry is always a well-established thing, but what about when we compare with other industries? This is a study by the Bureau of Economic Analysis. It's US based, and when we are comparing our construction industry with 4 other different sectors of industries, we find that our industry productivity, the bottom red line, is almost a flat line that is centered around slight oscillations around the 0 degree mark, and it has been in the decline. Whereas all other industries, even the agriculture, the implementation of the technology and everything, at least we see a linear progress, if not somewhat exponential in the case of manufacturing that we see. There are the reasons for that is multitude. We cannot say that this single factor is governing the data, and even the data that we see over here is more qualitative, and still a lot of debates out there. But the situation, even in the most conservative estimate, is dire. And we come up with something like there are of the construction, when we're considering the construction projects about that are completed, about 72% are completed over budget, about 70 are completed behind schedule, and of the 70, at least 50 are over budget. The point is that when we hit the number 70 or 75, you all would know it is a 3/4. That is the struggle which our industry is going through. And there is a analysis by McKinsey consultants that sets the sectors like construction to healthcare. In between, we have banking, we have aeronautics, aviation, there is hospitality, different sectors. The bottom most profitable industry is construction industry. And why? Even if business is always run primarily based on the profitability aspect of it, in spite of such hurdles in the business sense, construction is still a thriving industry because it is actually a basic necessity. And we, however economical or uneconomical things tend to be, we have no other go, but we need to have the construction industry always in the move, calling for efforts to make things better. And one of that efforts led us to the direction in which Lakshmi was talking about. We using the digital compounding effect of digital technology to integrate and better handle the data in our industry. So before I move on to BIM, I want to show one particular case study. That is this. This is, of course, one of the most recognizable infrastructure or building project ever developed. Anyone, even without a basic understanding of civil engineering or an architectural engineering, would identify the Sydney famous Sydney National Opera House. And I have titled it as a project failure. So before jumping into conclusion saying how can you do that, I'm just talking about the Sydney Opera House construction project and how that particular project is a failure in a strict project management sense. So what I mean is that I don't mean it is not a beautiful building. I don't mean that it has created a lot of revenue. What I mean is that when it was a project that was done close to 5 decades back, and the initial cost and the final cost is very different, and there is almost a 15 times factor that is coming into the actual cost of construction, which translating into current thing, current scenario, such a building, if say if it cost currently about $1 billion to complete. I may be over exaggerating, but think about it. And finally ending up $15 billion, investors will run out. It would be a really messy situation. Similarly, the same project was expected to complete within a 4 years time lifespan. Construction life cycle I'm talking about was completed within 15 years. So the overshooting of time also is very drastic. And as I am addressing like the students community over here, I would say that this is a very brilliant case study, and a lot of literature is available. Just if you can Google Sydney Opera House, why it's a project failure, you understand a lot about how the construction industry, in a very practical sense, has got a lot of inefficiencies and the factors involved. So that's something maybe you can take up from this webinar. And so the situation is dark or very bad. That's not we being an alarmist. That is we trying to say that understand where we are. Let's see what are the options for moving us forward. And this brings us to another interesting research that has been done by the World Economic Forum. This is the Future of Construction survey results. And here we are essentially looking at what is the impact and likelihood of adoption in the new technologies. So in y-axis, we have the likelihood of adoption, and in the x-axis, we have the impact of what would be the impact of such a likely adoption would entail. And at the sweet spot between the high impact and the high likelihood, we have something called integrated BIM. So this is essentially the product that we are discussing over here. Our product is also an integrated BIM management software. And why this term BIM and integrated together becomes very relevant, we would be understanding as we go on. But let's assume blindly that okay, it will integrated BIM in itself will have many in good properties, good advantages why it is coming in such a sweet position. And apart from the inherent potential of integrated BIM, it's the ability of integrated BIM processes to communicate with other alternate technologies like contour crafting or big data analysis or 3D printing. Like we get to, using this BIM processes, we get to communicate with even many of the newly emerging technologies in the construction industry, making it a very relevant topic for all of us to understand. And let's say BIM, like I graduated college a long time back. I cannot assume what is the understanding the current students would have. Like I may be talking about things that you are already aware of. If so, I'm sorry to waste your time. If not, I would like to bring your attention to what would be the impact of a systemic policy, a government supporting a BIM usage. What would be the impact of in the construction industry? And there would be 3 parameters like BIM. I have not heard about it. I know I have heard about it. And the third thing is I am aware of it and I'm using it. And UK is one of the countries that had a strong governmental policy implemented at the time around 2011, and which made it a technical criteria for every construction project, and to use the BIM process efficiency to mitigate some of the inefficiencies that is coming in the construction industry. And we find that from 2011 to 2020, in a very short span of about 9 or 8 years, we find that from 13% it has jumped to, the situation has reversed to around 73% using the BIM and adopting it and using it very seamlessly. So support and understanding and awareness becomes very important when we talk about such technologies. And we, all of us, are inherently adverse to averse to change. Um, uh, we continue to, what shall I say, avoid change if possible. But that's where you people, like the freshly graduate students coming into the industry, having the knowledge and working about working up information on how the situation can change. And as Lakshmi suggested, like, it is a technologically driven or data driven decision making. Data driven construction is currently being focused by all, even the Indian government, like the metros that we talk about, the smart cities that are being talked about, like even the Maharashtra, one of the project, I recently came to be aware that around 100 crore was set aside only for the project management, the digitally handling the project management part. So that is how big the uh, situation is getting, and that easily translates to job to skilled people, and um, you can become the torchbearers of such progress. And finally, when we talk about, we are essentially talking about the uh, how to tackle the inefficiencies. A key term, open BIM, becomes very essential. Why? Because we have something, we have a data, and that data can be used by three separate software packages. And the building life cycle is around 50 years. After 48 years, somebody is coming to look at how can I maintain the building, and he or she is restricted that you have this information, but you need to choose a particular software that is not probably ideal for what he wants to do, the activities and or the constructional activity that he or she wants to do, is kind of restrictive. So similar to the easiest analogy I like is that, like PDF is open, or docx is openable by any PDF reader, we need to have certain open formats of this BIM, so that it is the data that is generated and created in a meaningful sense can be used in throughout the life cycle of the building. And considering that even the smallest individual house has a lifespan of more than 50 years, the importance of such open data has become very important. And these are like some of the things that we need to be aware of when we are coming into the close. These are the kind of the broad guidelines that everyone needs to set in the mind before we delve into the specifics of BIM and specifics of Bexel Manager. So we talked about, Lakshmi started from who we are, like who Bexel Manager is. I continue, and she ended with the situation in the industry. I took on from there, and we spoke about what exactly we saw in a much more detailed manner, what exactly the situation in the construction industry is and why BIM would be required. Now we keep on using these terms, BIM. What exactly is BIM? Again, many of you would be aware of this, but under the assumption that a person with zero knowledge also is not handicapped in this webinar, let's have a couple of slides discussing about this in a very, very intuitively understandable manner, not going into the very specific details. So in BIM, we have something called an object, and an object is, imagine a building, any component of that building can be described as an object. So a door or a beam is an object, and you can list more, I am sure. So we are trying to, essentially, when you're trying to draw a 2D CAD drawing or anything, when you're trying to translate some thought process into paper, you are trying to define this object. And in BIM, we are trying to digitally represent this object and manage the informations that we are representing with this object. And 2D CAD that we draw either using some authoring CAD authoring tool, or even in the pencil and paper also essentially does the same thing, but it is has various levels to it attached to it. Okay, and the information that we spoke about here can be classified as two types. Like any object will have a geometric information attached to it and a functional information attached to it. So again, finally, we tried to make things simple and ended up with object, geometric, functional info, and things like that. So let's look at what exactly is a geometrical information. And for that case, I'm for that purpose, I'm using the simple door that we use in above our buildings as a reference object. So what all are the geometrical informations attached to this object? A door definitely has got a height, width, thickness, and a swing. And all these things, if you take 1 second to imagine the 2D drawings that you have produced, is captured in the 2D drawings in plan and section. And this is this enough? This level of information, is it enough for a person at construction site to completely build this particular object, that is door? Is there or any other information related to this door that a person would need? And that question leads us to the next type of object, type of information associated with the object, that is the functional information. And for a door, examples, like it's not exhaustive, but some examples would be: what is the material the door is made of? Is it timber or steel? Or what is the surface protection, like varnish or paint or bitumen coating or something? Like what exactly is the thing that we need on its surface as protection? What exactly is the fire rating that is needed? What exactly is the make of the door handle, or do we need a specification? It needs to have such level of security, it needs to have a twin cylinder, some particular locking mechanism. So that kind of thing. The material cost is actually needed. Like client, when they ask to like how much money would we end up paying, we as consultants or the contractors would need to have the um, an answer with minimum variation that is involved. And the labor requirements, what exactly are the number of people required? Is there a particular kind of tool that is required to handle this, install this door at site? All those things needs to be looked into. And finally, even imagine that the door is constructed at site. The situation, like as I said, is the door is going to be probably used for a lifespan of 50 years. What is the maintenance cycle? Do we need to revisit at every 2 years or 10 years to check whether the quality is good? What exactly is the um, maintenance that needs to be done, or quality checks that needs to be carried out? So you see, all these functional informations are also attached to the same object, and with BIM we are making sure that the geometric and functional information is coming together in a meaningful manner that can be used across the life cycle of the product. So that last part, across the life cycle of the product, let's look into the information that we saw previously. All these information, kind of in the previous slide, we saw around 7 functional infos. Are all these informations made at one single go? Probably no. The answer is no. And to understand that, let's look at these 7 functional informations from the life cycle of a project kind of perspective. And this 4 information, if you can see, the timber, the surface protection, all would be probably done that decided at the design stage by an architect. The material cost would be carried out by a costing consultant, but that's a separate person and a separate life cycle, separate part of the specific part of the life cycle that material cost comes to play. When we come into the labor requirements or the time involved or all the sequencing activities, a planning engineer would be involved at this for this same door. And when we talk about the maintenance cycle, it's clearly a construction activity. So even this, within this information, you see that many information is added at later stages at different points in the life cycle of the project. And that's where we come in. Like, we as Pexel manager wants to have a proper integrated software platform where all the BIM management tool cutting across all the life cycles can be managed. And Hence, when we talk about Bexel Manager, we add one more word before the BIM management tool, that is the word integrated. And that word we will keep on repeating throughout this webinar. So we talked about BIM in a very, what shall I say, in a very representative manner. It might not be the actual details. So coming to the previous information that you saw about the doors, coming to a building, how is it captured in our software or any BIM management software for that matter? This is a snip out from our software package, Bexel Manager. And you can see that what we are seeing is a building explorer having a lot of sub elements or categories, is the term that we use. We have got air terminals, objects like related to air terminals, beams, cable trays, and so on, even door. So this is how we get the information into the software. And coming to the specific example of the door, let's take this. AR is related to the architecture. This is a double wall. Some properties are associated with the objects, a subtype, this particular subtype, and that is captured as shown here. Again, you can see this is not a complete information, just for your understanding. It has got dimensions, it has got materials, it has got different even you can see the hinge sets, all the information which you can imagine can be included, added, edited, basically managed in this platform. And we talked about the geometric and functional thing for a particular door. And when we look at the same narrative that we just had, for a large and complicated stadium project, this is one that is completed using Bexel Manager. And here you will see that how the different parts of the jigsaw puzzle is coming together. And we have something called level of development and level of information. So imagine this as for those who have studied structural engineering, you would be setting, okay, the load can be taken, a minimum standard or minimum strength is set, or minimum requirement is set. Something similar is set with the level of development and the level of information. We are at the start of the project saying that when you are developing the information, we need so much of the information in such a manner. So this is an initial expectation of how the project should take shape, and these together brings out the complete BIM model. Yeah, and when we're talking about BIM, one another concept or use of term that we commonly see is the federated BIM model, and that is nothing but you have different teams working. When we are strictly in the design sense of a building or an infrastructure, we have different teams working together to build this building. For example, the structural team would be responsible for developing the structural elements. The architectural team would be responsible for the facade and all the spaces aspect of the same building. And the MEP team, the mechanical, electrical, and plumbing team, would be responsible for developing models related to the same building. And all these three separate teams' information should fit together to form one single model that can be taken apart together, to put together and dissected to create meaningful information. So that single source of information, using different information from different teams, are called in BIM. When it comes together, it's called a federated model in BIM. So try remembering this term when we are continuing with the discussion about BIM. And this sums up a talk about what exactly BIM is. So to recap, until now we have talked about why BIM is required and what BIM is. Now let's see how Bexel Manager is very efficient, and why do we keep getting recognition in the BIM software platform because of our integrated BIM management tool. So that is the section we are starting on from now onwards. So I want everyone's focus within this green rectangle, where we are trying to put the different aspects of Excel Manager in a very qualitative manner. So starting with the input, let's say any software. So any software, any code, anything that you write, it has basically some input, the way we process it, and some output. Excel Manager also is something very functioning in the similar manner. Input for us is a 3D BIM model developed in authoring tools such as Revit, and this input brings us the access to BIM integrated data levels, and we get to manage this data. Our one of the advantages of Excel Manager, why we are very robust in the automation aspect of things, is that we have the ability to create different templates. And templates, for example, the exact meaning of these um, terms would be irrelevant at this stage of understanding. What the templates mean is that, for example, I am owning a construction firm that builds private villas or individual townhouses. So the kind of construction that I carry out is very similar. From one shifting from one project to another, the kind of information that I would be handling is also very similar. So once I set up for one project, a lot of things that can be reused. Instead of recreating this information, I can create a template that can bring in the power of the previous knowledge into the way we function within Excel Manager, and that's what exactly the templates of Excel Manager does. Now comes the most important part: the input. The one part of the how we process it is the automation is handled by many templates and rules. We do have the processing engines, like we have 5 separate processing engines. It is it can be said that it is integrated as well, like from one information from one is used for the other, and the vice versa. So that's also there. So these are clash detection, QTO, costing, scheduling, 4D, 5D, smart scheduling, and how we track progress are the engines basically that the information that is handled by the Excel Manager. And finally, the output. All this information needs to be comprehensible. Like why we importance of that is that even a small 7-story building, the schedule, if we prepare in a detailed manner, can end up in something like 10,000 line items. And hence things are, and even the most experienced person will not be able to make sense of that large information. Hence, the output, how do we represent the information, becomes very important. And we have got very robust reporting systems that later slides we will be displaying for how we are capturing such information. This is just what is happening within Excel Manager. And like any ecosystem, Excel Manager is not an independent thing. We communicate with a lot of things outside of this green rectangle, starting with our own common data environment that handles many things like facility management and uh, document management systems. We have our own online viewer where you have the right file. We can use very low computing power requirement devices like even mobile devices to handle see the information that is structured in the Excel Manager in with to sufficient details. And there are other things like communication with Power BI, Microsoft Power BI, for creating very good analytical graphical representation of the analytical data and things like that. And finally, not finally, I'm sorry, the knowledge-based management. This is kind of the standards that we set, and this is where also the open BIM concept that we talked about in the previous, some of the previous slides come into play, where we are using the IDM and IDS systems, the classifications and the cost databases. That's not just it. BIM, you will when you start working on the BIM processes, you will see a plethora of softwares that are available, and starting with the most famous, Autodesk Revit, and Bentley, Tekla are all the major players of the different segments of the BIM processes. And because we promote open BIM, allows the communication of our file format with all the softwares in the standards that standards that are called two. Basically, IFC is one of the standards, and another is the BFC format. BFC basically stands for BIM Collaboration Platforms, and IFC stands for Industry Foundation Class. So these are just file formats that we use for standardizing the communication interoperability between different software packages. And all the information we spoke about till now is BIM, and we are operating in a construction industry that is severely non-BIM, and hence the need for us to communicate, export, and import data from the non-BIM softwares like Oracle Primavera, MS Project, and Excel, which is also we are able to handle very robustly. And finally, customization for client requirement is also another thing that Pixel Manager is able to handle. For example, SAP ERP kind of customization, if required, can handle using add-ins. Now coming to the BIM lifecycle, we say that Bexel Manager has visibility or capability to handle information in all the BIM lifecycles of the project. So the different BIM lifecycles are the BIM 3D BIM, which involves clash detection, visualization, and quantity takeoff. When coming to integrated 4D, what we mean by integrated approach over here specifically is that we have costing two things, time and cost. So costing comes in the POQ or the costing other line items, and the schedule comes in the time part. And one is dependent on the other. So the costing person who decides that instead of one resource, he will implement 5 resources to handle the same task, it will have a direct impact on the schedule. And similarly, the scheduled person who decides that instead of 5 days, he will be stretching this activity to 10 days, will have an impact on the cost. Hence, the importance of the integrated BIM. And over here, we get to communicate between the cost and time aspects, and we get to track the progress, we get to check the planned versus actual analysis, and finally the reporting. And that's not just it. Till here, let's say, is the finishing of the activities. Once all the construction activities ends over here, then the facility management and all other things comes into play, and that is handled by our the CDE environment. And this two aspects of the 3D and the 4D BIM would be the primary focus of this what we are discussing over here today. So I keep talking about 3D BIM, 4D BIM, 5D BIM, 6D BIM, but all in the construction industry are very familiar with some other terms. The project management sense, we do not use the term 3D BIM. We use something like design, budgeting and tendering. We use construction planning, construction, and operation and maintenance. And the same thing in the BIM, when we are doing the same processes using BIM, we use the terms 3D BIM, 4D BIM, 5D BIM, and 6D BIM. So it's not complementary things. It's the same process having two different names because of two different approaches. And that is what is captured in this small snippet. So we have got the BIM process flow over here in the central part. And what is exactly the life cycle of the project associated with this particular aspect is the bottom line of information. And in the top line of information, we see the same thing in the BIM perspective. So you need to understand that when we talk about design or when we say 3D BIM, we are essentially talking about the same processes. So that with that, you can see that all these are the kind of information that we generate using Bexel Manager in different project life cycles. And quick break from Bexel Manager to see some brilliant construction. And Petronas Tower is what I would like you guys to keep in the back of your mind when we are talking about the complexity of the construction, the complexity of the information. So when we talk about a simple construction like this, it's billions of around 6 billion, 1.6 billion, 6 billion USD was shelled into building of this project, and that has 88 stories and a lot of big information, like the kind of information that can be needs to be handled is kind of very high and busy. And using our Bexel Manager, we have something called steps of progress, or what we call a workflow. We start with the input. As I said earlier, we have something called the 3D BIM data that is generated in a authoring tool such as Revit is the input for us. What we do is we start with the geometry. We get something. We get an input. What do we do first? What we do is we see whether it is like we wanted it. We will say, we'll check whether is there any error. We do all the verifications, and we finally either make some changes, or we say that okay, the quality check is good enough, we can go for the next step. And for the next step, we start with something like creating and fine tuning of the cost. Then there is something called cost version, which is essentially a budget. And from there, we have something called methodology and zones for creating an automated smart planning schedule. Automated schedule creation is final step. So these things are not intuitively clear. The intermediate steps will not be intuitively clear to you. I would be explaining all the intermediate step in detail. So what should be clear at this stage is that we have something called input, and we would be verifying it and checking it, the quality of that information using Bexel Manager, and finally ending up with something called automated scheduling that utilizes the efficiency of our software. Coming to the 3D BIM, let's start with clash detection and move on to the other things. This is one particular aspect. Like there are different type of clashes that can come in a construction industry, and let us take explanation on one particular clash will lead to the clear understanding of what exactly the others can be. And let's talk about the clearance clash. We have diagrammatically what we're seeing is two cuboids representing two different objects. Let's say we have something called a beam and something called a AC duct that is going through the beam. And we, as designers, will be aware that the duct probably will need some insulation, and because of this insulation, there would be a clearance requirement of say 50 mm between the duct and the beam. So if there is not the clearance between the beam and the duct is less than 50 mm, that would be a construction clash at site, and tackling it would be of difficulty. That tackling it at site would be difficult. So that's what we mean by understanding. Using our software, we get to run codes to check and understand, okay, is the rule that we set saying the 50 mm clearance between two specific elements is a rule that we set. We check whether such is anywhere in the project, this rule being violated. We get to understand a violation of rules in all these manners, and we get to solve them before we start constructing. And that translates to a lot of saving in the a financial saving. And it's studied that one conflict at construction site is equivalent to a large amount of money. And this single piece of information might not be like when we have $1 billion project, saying 75,000 rupees might not be a big deal. But when we understand that at site we are usually dealing with thousands of clashes, this value gets multiplied with so many clashes, and hence we doing clash detection and ensuring the quality of the product that we are making becomes of importance. And this is some of the clashes that we have done in some of the projects using our software. Over here, what you see, the red, this red element is a beam, and we can see that the green duct is passing through this is a clear clash, and which we can ask to be resolved at different stages. Similarly, a few other clashes I have represented over here. So basically, clash detection is dealing with the geometric, what should I say? Geometric information validation is what a clash detection represents. So let's say we found out all these clashes and we made sure that such clashes are resolved. We are now sure that the geometric information that is present in the BIM models is very correct. The quality is passable, and now we can start constructing it on site. But like I said, BIM has two components, not just the geometric, the functional aspect of information is also there, which we do by the data validation. And for data validation, again, we have the input, which is the BIM model. We have pre-developed, our technical team has pre-developed many API scripts that are customizable to our requirement. And this API scripts essentially sets a checklist of, say, for example, a beam should have such information. And basically, once we run this input through this script, we get that, okay, it is possible. It has got so many warnings. It has got so many errors that needs critical resolving, and things like that is generated. Essentially, the functional information quality check is handled using our data validation. Now, say we have validated and found that 10 errors are there. We have also and developed scripts that are again customizable to enrich our model and make sure that the errors that are coming in the data function can be addressed, and the not just the geometric information, the functional information is also in the level in which can make meaningful sense in the construction site. So this is what we talk about. We have the geometric information, we have the functional information, and how the quality checks are done for the both of these are essentially what these topics of data enrichment deals with. So essentially, when we are saying we are done with the data enrichment, we are saying that, okay, the quality check is all done. Now we get to use the information input, and we can start managing it. The first thing that we would do is a quantity takeoff. Anyone who has done the basic paper on the quantity and estimation, it's basically a manual calculation of the volume and or a surface area or something else. You need to calculate for each and every component of the building, and what we say is that it is actually a repetition or reinventing the wheel or repetition of information. We already have got a 3D model. We are wasting our time and energy if we have to recalculate the information. So instead of manually calculating the quantities, what we do is that within this breakdown, we say that of all the elements that are around 10,000 elements are available in the particular project, I want that information, those elements to be categorized based on some formula, category and family. These are terms, okay, like that are very commonly used in them. And of that, I want the quantities, these many quantities, the volume, the area, length, reinforcement, all these things that are already associated with the 3D model. I want that information presented, and this is exactly that something that used to take months for a complicated project. We are able to define very easily using this logic. And this is actually a very good value addition of the way we function. And when we are talking about creating alternate workflows to make things more efficient, this is exactly what we talk about. So another key area that we can handle use in the 3D BIM level is quantity takeoff. And now we are starting with something else like the cost management. And so we have the quality check done, we have the values done. Now we have the cost management system, which can be done for in two manners. Like one is using this is the one starting point. Another is the alternate starting point is I am physically trying to show it. What exactly it is? Let's look at a deeper manner. So first starting point is in the previous slide we talked about cost classing, quantity takeoff, right? The quantity takeoff that we have created, we can use this and automatically create cost classifications. So we have the quantity, what is the cost attached to it? So based on that we can automatically create, and we can use our expertise to fine tune this cost to create meaningful cost versions. Another way in which we can create, so over here we have already a cost version which can be translated to an integrated cost data. So this is one process. Another process is we have got many international standards available that are Unicode, or Uniformat, or Master Format, different. This DIN is based on German construction practices. Unicode format, I believe Uniformat or Master Format, either is used for Canadian, and so different countries have got different standardized practices, and using such standardized practices, we can get it such practices in through our into our Excel manager, either through API scripts or using Excel spreadsheets, and finally fine tune such inputs to create a integrated model of cost data. So this information is has two outcomes. This is linked and integrated with our construction schedule, like I said in the previous slide, and we can also, the data that is churned over here can be expressed as expressed and reported in different formats. Basically, Power BI is very popular among the top management for quick understanding of big data. We have then different comparisons possible, export in the IFC format possible, and multiple other ways in which we can use the information that has been created over here. Finally, when I said that the information created over here is linked to the intelligent construction schedule, let's look at how this particular aspect is created, and then let us try to understand how this linkage works. Hence, coming to the intelligent scheduling. And for intelligent scheduling, we start with something called the integrated cost database. That is the previous slide. So this is what when we talk about the integrated cost database, this information that is previously created, we are using it for as to be linked with our scheduling engine. So I want everyone's attention to two aspects, two words: define zone and define construction methodology. If we try to understand these two things, how we will understand how Bexel Manager is able to create an intelligent schedule. So first is zone, second is methodology. Zone is a spatial representation or spatial organization of the project. For example, a building, when we say has 11 stories in it, it has got first story, second story, third story, fourth story is a spatial arrangement of data. And when we instruct when we describe a zone as two is coming after first, or after first, second comes, after second, third comes, the Bexel Manager software will understand that, okay, this is the way in which the vertical information is stacked, and we will avoid the error of 6 coming after 5, or some error can be handled in this manner. Another spatial information is the horizontal one, which is like the buildings being constructed in phases, like phase 1, phase 2, phase 3 is one horizontal spatial information. Another way is that building 1 and building 2, like we have two buildings. After completion of building 1, building 2 needs to be carried, construction works needs to start. So such kind of precedence in the horizontal information of project organization is handled using the term zones. And when we talk about then we talk about something that is methodology, or what we mean is that the work sequence definition. So what is a work sequence? Over here in this building, we can say that first it would be the piles, then it would be the comes the pile cap, then there will be the slab, then there will be the tie beams associated with the pile cap, or some, and then we have the columns, walls, and that's how but one particular work sequence goes on. And for each of these, for example, let's say focus on one single column. Each column has got construction finishes, concrete placing, reinforcement placing, and CIP, cost in place forms. So these are the the work sequences in that is happening. So we have something called spatial organization and the work sequence, and intersecting both we define. Once we define these things, we intersecting of these together, we can automatically generate schedules. So that's what basically we do. So we have got this is a complicated lot of information is available in this slide. So let's break it down. So here you can see the different 5 columns, right? Let's say building 1, building 2. So correspondingly, a graphical representation is happening here. This is the zone 1. Then this 5 elements is methodology level 1, which describes that from columns, then structural roofs, or then walls, the precedence of activities, construction activities is set over here. And the next column, we are setting the precedence of activities for each of these elements. For each structural column, for the formwork should be succeeded by reinforcement with concrete pouring and concrete finishing. And then comes the next level, that is the all this information should be carried out, first constructed in the sub level, then should be carried out in the entry level, then should be carried out in the second floor, and so on up to the roof. And finally, we say that all this information would be first carried out in the phase 1, then phase 2, and phase 3. So we have got all this information. Like, how many information do we have? Around 20 individual information we have, and all these are linked and multiplied to generate, let's say, 2 times like finally multiplying all this information together, we'll end up with 1,000 or 10,000 line items in the schedule. And that schedule is something a person with very high experience can imagine to work if not created intelligently. What I mean is that let's, for example, say that after the schedule is fixed, the designer says that because of some plan or some change, another 500 extra columns are coming into play. So somebody needs to rewrite everything so that this change is adopted, and it becomes a very tiresome process. Change management is very difficult in civil engineering. But since our system is intelligent, it will automatically identify that additional 500 columns in the structure category and update the schedule that we created to automatically include the additions, and change management becomes very easy. So this is a video that I would like to share at this moment about how the intelligent management is going about, how it is actually implemented. All the theory that I talked about until now, how is actually it is happening at the software level. So this is the zones, that is the spatial information that we are creating. This is the methodology that we are creating, that is the workflow of information. And finally, intersecting of both is this particular aspect, the auto generation of the construction schedule. It's a wonderful process. My major experience is from a structural engineering background. For me also, it was very intuitive and easy to, within 2 days I was able to generate very detailed schedules. And that's one of the, I say this, our software essentially removes a lot of entry barriers, and maybe 5 days of very focused attention, a person can very intelligently use our software to create meaningful information. And this is one of the byproducts of all the rules that we set, is that we are able to generate automatic construction scheduling videos and generate a lot of Power BI templates where we compare the cost, the earned value, all the graphs, and all the information that needs to be handled. For example, the cost performance index, and all those information together, bringing it in one sheet that can bring out the total information is doable. So this is the complete workflow in 2 seconds. So it is it is not as difficult as it looks, and it's not as easy as it looks. That's my take on it. Right? So that's one video. We have few more videos for so that you understand how whatever theoretically whatever I'm talking about, how it practically gets reflected in our software. So this is some of the information that we can be churned based on the rules that we set. This is another example of the information that goes on. This is actually a serious scenario analysis. We have two types of plans, option 1 and option 2, for a transmission tower. In option 1, we are constructing 2 towers at a time. In option 2, we are constructing 1 at a time. So what exactly is the advantage in terms of cost and time, we are fairly understanding. And n number of scenarios can be easily handled using our scenario, and better and more efficient decisions can be taken. For example, in civil engineering, decisions are like, let's not waste more time, let's go with this kind of blanket approach, is not essentially the most optimized information way of doing things. Here we understand that option 1 takes about 4 months to complete, and option 2 is 8 months. So when we go to the client and say, do you take precedence of time over money or money over time, such kind of scenarios can be very easily understood. Finally, we have the cost, the how schedule, indicating how the information is needs to be constructed at site. And finally, once the construction begins, is the construction sticking to the schedule? Is there a delay? Is there a ahead of time type of activities? So all those progress tracking is very comfortably handled with using our inbuilt packages. And here you see that we get to customize our according to our requirement. We get to customize with minor changes to the already available API scripts. And this you can see is that is a monthly task look ahead. So each month so for example, this particular month is from this time to this time, and this is the activities that needs to be calculated. And here you see a BCF is the BIM collaboration format. So here we get to communicate with the site engineer saying, okay, this month, this many number of activities needs to be completed. How many did you complete? Where he can review, send us back the information, and we get to update and track the progress using our software. Again, this is for the, again, the scenario analysis. I said, like, it will have cost impact and time impact. So the plan 2 is taking more time but less value. Then it's an executive decision, executive call to say that, okay, that cost is comparable, let's go with the plan A. Okay, I need to save whatever small margin of cost, and since it's not a critical activity or time dependent activity, let's go for plan 2. Such kind of decisions can be generated using our software. And finally, these are some of the reporting and analysis. Like, you can see, imagine, recall to your brains the Petronas Towers. We have got 88 stories. We have got probably a 50,000 line item schedule, which no one, like Gantt chart of that scale, no one can comprehend in a single manner, and however expert he is. So getting the meaningful information that can be handled to generate quick decisions is what we try to implement. And things like Power BI, Microsoft Excel, and all these other formats are ways in which we get to generate the information that is created in our federated models. And this is something that we are very robustly able to handle. Finally, this is an actual simulation, 4D, 5D simulation, done using our software for a hospital project that has been recently constructed. And you can see what you see. What I see is that in a sequential manner, we generate an intelligent schedule. If somewhere our logic fails to correctly capture the information, if a construction error is made, that can be very easily captured using such graphical data. And that is essentially what we do using such simulations, other than the very quick and aesthetic part of it. So this is a very relevant thing that, and this data is automatically generated when we set the rules using the zone and the methodologies. And what we need to understand is that such kind of information can be customizable and even sent to very um, good softwares that handle such kind of simulations, such as Unreal Engine. So that kind of communication is also possible using our software. So this is something else that we are really good at handling. And finally, facilities maintenance part. I would like to skip this part because I feel that there is an overburden of the information from our end also, because you would also like to take a lot of time to process the information that we have shared until now. So these are like some of the informations that I would like to skip through. This is because it's already been talked about. Finally, I would like to conclude that when we first approached TKM College team, Dean Professor Seema Madam, she one thing she was told us in the first go is that I don't want you to sell your product to my students. I want you to understand what they would benefit from. So, and what would they can gain. They should gain something from this rather than understanding about all the glories of Excel Manager. So from that perspective, we would like to conclude by saying that Excel Manager, when we are talking about the next generation of digital construction, we are talking about automatic updates of all the analysis, the change management that is very easily doable, the disruption analysis, like different scenarios that can be handled, all those things that can be handled using our software, and archiving all the versions of the one particular project. As you will, when you are entering construction industry, it's the changes are very dynamic. Like the client would say, the client requirements would change, the structural detailing requirements might change. So all the versions and how the changes are impacting the schedule and cost, keeping track of all such complicated information is very much possible with our software. Then is the updating of the schedule and optimization of the workflow of cost is very easily handled. So these are some of the high impact things that easily results in our the high return of investment when we are using Excel Manager to manage the digital data. Of course, we need to understand all this from the sense of a context of why we are doing all these things in the first place. It is basically for improving our construction productivity. And finally, I would like to invite Lakshmi back with us to continue. This is like I would like to stop the technical presentation now, and I would invite Lakshmi to say why and how you should engage with us and proceed with the journey of improving construction productivity with Excel Manager. Yeah, thank you. And Lakshmi?
It's nothing. It's basically, I just want to tell everybody to be a little more, active in LinkedIn, because it's the professional space. Just connect with anybody from BIM area. BIM. It's not completely. You have to connect with us. It's basically like go and do up your profile and connect with anybody from the BIM area. And we are just kind of starting a community for construction management with the Open BIM, because it's a community where a lot of IIT professors and NIT professors are going to be invited. So you could get to know what is BIM, integrated BIM and open BIM. We'll be discussing a lot of things. You could connect it with a lot of professors in this field also. If you want to go for higher education, or if you just want to go into the field right now, like in the construction industry itself. So these are some of the things you have to get. These are some of the advices we just have to give to you. So with that, I think we would conclude our presentation. If you have any more doubt right now, you could ask us, or otherwise you could connect with Havilet for any more doubts with BIM or any Excel manager or anything like that. So I don't know the process, how it is through your faculty or directly through Havilet. It's totally up to you. So we're just going to conclude. Thank you once again for the patience. Thank you for us to complete this particular thing.
Thank you, Ms. Lakshmi and Mr. Madhav for the wonderful presentations. And we are grateful to you for opening before us this beautiful and big world of construction. I hope that the students would interact with the speakers. You can clear your doubts. You know, it is not an easy thing because this is something totally new to them.
No, we totally understand, ma'am. Thank you anyway. But it's basically an information overload because they are just studying right now. We totally understand about it because the big wide world out there requires a lot of other things. Requires a lot of softwares. It is not basically what you're studying cannot be applied in the industry itself. We totally understand. They have to take their time to understand our complete software. So we are ready to wait. They could connect with Havilet basically. So any more doubts, we'll wait through them.
Ma'am, hello.
Yes.
So could you please tell about the tools that is needed to know to get an introduction to BIM for beginners?
Like I said, BIM begins like one of the most popular areas where we begin is the authoring, 3D authoring itself, maybe a Revit or something like that. So my sense, my take on it is that understand the big picture, like what exactly is the project life cycle. It's a very simple thing. Then what are the traditional softwares that can come, maybe the Primavera. So make sense of the life cycle, make sense of the different softwares that are used for different life cycle, and maybe experiment with a couple of softwares here and there. So once you understand the bigger picture, you can plug into any area and efficiently. Like maybe BIM is a starting point, you will find many difficulties, but understanding few definitions, maybe actually downloading a BIM and working around with it would be a good place to start. And we also like if you have a BIM model, like a Revit file from somewhere, just try downloading Excel Manager and playing around with the parameters to understand that it's very easy. It's like I said, it's very easy and it's very difficult. It's very easy in the sense that it's very easy to actually click and do the processes of Excel Manager or any software for that matter. It's very difficult in the sense that to make meaningful information, garbage in, garbage out, good information in, good information out. So that sense comes from practice. So start somewhere, start anywhere. So anywhere is a good place to start. Yeah, I'm sorry if I.
Thank you, sir. Thank you, sir. Do we have any other questions from anybody? If not, we could wind up the session. So I'd like to welcome Sandra for proposing the vote of thanks.
Good evening to one and all present here. It's my privilege to offer vote of thanks on this event. First of all, I extend my gratitude to our honorable instructors, Mr. Madhav Srikumar and Ms. Lakshmi and Suresh. Thank you for your efforts in taking such a wonderful session for us. We could really get to know more about building information modeling. I would also like to thank our faculty advisor, Dr. Seema Kinayar, for arranging the session. I also thank Dr. Kishore P., Mr. Abhishek, and Mr. Suresh Kumar Nair for gracing the event with your presence. Also, I thank Adul Venugopal for the beautiful poster. Finally, thanks to all the students and other faculties for attending the entire session. Thank you all.
We also had a wonderful time. Thank you.
Thank you, sir.
Thank you, sir. Thank you, Lakshmi. And thank you, participants.
Thank you.
Thank you.